Let us discuss a few properties of diagonalizable matrices. If the square matrix A has n distinct eigenvalues, that is, none of the eigenvalues repeat, then it's sure that A is diagonalizable. But the converse need not be true. That is, if it's given that square matrix A is diagonalizable, then it need not always be true that A has distinct eigenvalues. That is, even if A is diagonalizable, it may have repeated eigenvalues as well. For example, consider a square matrix A. It's a diagonal matrix with diagonal entries 2, 2, 1. Here, the eigenvalues of diagonal matrix are just the diagonal elements, and hence eigenvalues of A are 2, 2, 1. 2 is the repeated root. Let x1, x2, x3 be eigenvectors corresponding to eigenvalues 2, 2, 1. If we wish to find out the eigenvector corresponding to the eigenvalue lambda equals 2, we have the equation matrix multiplication A minus lambda I into x1 equals 0, where lambda equals 2. And when we carry out the matrix multiplication, we have two rows which are 0 rows. From the last row, which is a non-zero row, when we carry out the multiplication, we obtain an equation from which we get x3 equals 0. We identify x1 and x2 as free variables. At points x3 equals 0, x1 equals 1 and x2 equals minus 1, we have eigenvector x1 equals 1 minus 1 0. At x3 equals 0, x1 equals 0, x2 equals minus 1, we have the eigenvector x2 equals 0, 1, minus 1 0. We can see that x1 and x2 are linearly independent. So corresponding to eigenvalue lambda equals 2, we are able to get two linearly independent eigenvectors. We wish to find out the eigenvector x3 corresponding to the eigenvalue lambda equals 1. We carry out the equation matrix multiplication A minus lambda I into x3 equals 0. We get x1 equals 0, x2 equals 0 and x3 is a free variable. Hence, we can have the format of the eigenvector corresponding to lambda equals 1 as x3 equals 0, 0, k, where k is a non-zero scalar. Since we obtain three linearly independent eigenvectors x1, x2, x3 and the order of matrix A is 3, we can conclude that the given matrix A is diagonalizable even if it has repeated eigenvalues.